Ladies and gentlemen, recently I came across one of the interesting try-hackney rooms, and the room is all about uh, small reverse engineering and a little bit of exploit development. I'm so excited to share that experience with you. Without wasting your time, let's begin. Here is the challenge. The challenge name is DearQA. Are you able to solve this challenge involving reverse engineering and exploit development? I'm so excited. Let's begin. Actually, the exercise is very simple. There are two tasks. The first task gave the binary file. It gave the binary file where we can download the binary, and we need to analyze the binary offline. And the next task, it is having a machine. Actually, I already started the machine. It is already running, and look at this statement. There is a service running on port 5700. Start the machine using green button on this task. We already started this machine. They also mentioned about a port. So let's see what it is. First of all, we can run the nmap scan against this particular IP address and sudo nmap -sc for default script, -sv for enumerate version, and hyphen on to store it in the nmap format, and hyphen p hyphen for all port scan, hyphen vvv for enabling the verbosity, and finally pasting the IP. So this is what the command to run the scan for all ports against that IP. And fortunately, I already have it on my machine. I already ran that. So let me open it with Sublime Text here. So this is the scan result, the same command I used. Let's see what are all the ports are open. Uh, this machine is actually a Debian machine, and port SSH is enabled. It is running on port 22, the default port, and RPC bind is running on port 111 TCP very well. And you can see the port 5700. We have seen it in the exercise. Port 5700. Actually, it is running some support assist. So that is what the service name they mentioned. If I see the fingerprint here, I can see welcome dear QA sysadmin. I'm new in developing. What's your name? So you can see the string here. So look like it is displaying a message and asking for our name. So it looks like this particular port is running the binary. Uh, so this is what I wanted to showcase here. Port 5700 is running a binary. We just made sure with the nmap scan. Perfect. Now, let's try to answer the first question, which is very simple. What is the binary architecture? I already downloaded this file, and I'm keeping it in the same directory here. So this is the binary file that I downloaded. I'm using file utility to check its file type. So if I say this, I can see the particular file is ELF, executable linkable format, 64-bit LSB, least significant bit executable, and it is 64-bit architecture. Okay, and it is dynamically linked and not stripped. So these are all the some of the keywords which I mean denotes the properties of this binary. Dynamically linked means all the dependencies and the dependent libraries needs to be loaded. It is not already present in this executable. That is what it is almost mean. And not stripped, another keyword. And apart from that, we can see they also mentioned that it's GNU Linux. I think they mentioned the compiler here. So this is what I wanted to showcase with this. So let's try to apply another utility called strings against this executable. Strings is the utility to display the human readable strings present in any executable. Okay, now let me execute this. If I execute, I can see the strings that are involved in this particular executable. Let me read that. Uh, they gave some dependencies here and some function name here. Here you can see the function scanf is called, and printf is also called. So these are all some function names. And if I continue to scroll down, I can see congratulations, you have entered the secret function. And here is the juicy stuff. It is calling bin bash. So note this. And also Another string, welcome dear QA, I am sysadmin, I am new in developing. We have already seen this particular three line in Nmap scan. So this is one thing. And if I continue to scroll down, I can see another juicy stuff here. VULN. I'll let you know what it is. Before that, let's try to read it completely. And here is the main function string. So this is what I wanted to showcase in by using the string utility. Now let's try to execute that executable. If you are dealing with any malicious or unknown executable, try to avoid this step. Since it is a try hack me exercise and it is not the malicious one, I am just willing to execute this directly on this machine. So dot forward slash executable name, enter. Here is the message. Welcome dear QA. I am sysadmin. I am new in developing. What's your name? My name is Perumal Jagan. And yeah, here is the outcome. Hello, and it took the first word. Hello Perumal. So it is simply getting the output from the user and displaying it back to us. So that's what the simple function subscribe. Yeah, hello subscribe. So this is the simple executable, but by executing this, we couldn't see much information, but we can do one thing. It's a binary file, so even if you open it with notepad editor, you won't be seeing anything here. So this is just binary digit machine language, so you cannot read anything, but there are some exclusive tools to read this binary. Let me use one of such tools before. Here it is opening, and let me choose that file to disassemble. Here QA, and here is the file. Now the file has been loaded. So once the file is loaded, first thing you need to do is moving to the main function. So I just moved to the main function. Now I'm in main function. If you see this, uh, this is the format called assembly language. It's an intermediate language, the language that lies between the human readable high level language and the machine low level language. And however, this language is human readable. However, which might be very difficult for the beginners to analyze. And to make it very easy, I just chose this main function and choosing F5, pressing F5. Now, once I press the F5, I can see a new tab is opened. The tab is called pseudocode. And the pseudocode simply demonstrate the same assembly view in more user-friendly view. And if you see this, you can see the string, human readable string here, and it is getting the input from the user. As we have seen while executing it, we gave the name, right. It simply displayed the same name back to us. So it is getting the input. To get the input, it is using the function scanf. In C language, the scanf function is simply taking the user input without applying any filtering on user input, which means this particular user input point might be vulnerable to buffer overflow. So that's what we need to check here. If it is vulnerable to buffer overflow, then we can exploit that vulnerability and make this function, change this function's control flow. So that's what we need to do. This main function doesn't contain anything apart from this input retrieval and displaying the input. It retrieves the input from the user, and again it is printing the same. The next line you can see it is printf. So it is displaying the same thing here. So let me try to rename this particular entry here, rename lvar, and here I am renaming it username. Now I renamed it. So this is what this function. But along with this main function, if you see the nearby one, vuln, if you move here, you can see the string. Congratulations, you have entered into the secret function, and f flush std out, and it returns it is executing bin bash, which means this vulnerable function by default is not being called. It is just a dead function. It is not being called in the main function. However, if we manage to execute this vuln function, there are some possibilities to uh, bring the bash shell from that machine. So that's what we need to try now. Maybe we can do one thing. We will try to exploit this buffer overflow and try to make this executable to call the vuln function and make this executable to call the bash shell of the machine that we want. Okay, so let's try that. But before doing that, let's read the main function once again. The assembly view. Here you can see the 20 hexadecimal value is being assigned to stack pointer, which means they are assigning the buffer size to get the input from the user. And the buffer size is 20h, 20 hexadecimal. And the 20 hexadecimal, when you convert it to binary, sorry, decimal, it gives the 32, which means the buffer size is 32 bytes. So what happens when the user input exceeds the 32 bytes of input? At that time, it will experience the buffer overflow, and by that time we will be able to manipulate that executable. Let me explain it in a clear way. Here we have seen the vulnerability, I mean the vuln function. This function is not being called by the main function, but by manipulating the user input, we can call this vuln function. We can make the executable to call this vuln function. I can see the executable. Let me give the input here. When I give the continuous letters A up to certain limit and enter, it gives me the segmentation fault, which means this particular input exceeded the buffer size, 32 bytes. So we got this particular alert. Now this is where the buffer overflow exists. We are going to manipulate that. So let's do that. Let me explain how to do it first. Uh, Actually, we need to make the executable to call the vuln function, right? But we don't know the address of this vuln function. To know the address of this vuln function, we need to move to exports tab here. If you move to exports, you can see the address of this vuln function, and here is the address, and I can also call that value here. I can copy it. I can store it somewhere here for future reference. So I got the address of the one function. Now all I need to do is to create the exploit. Let me explain how to create that exploit. I'm creating a new document, and and let me define the syntax here. Python, and from pawn, I'm calling the library called pawn, and import all. So I'm importing all the libraries, all the functions from pawn library, and here I'm defining the host IP. So define the host IP here, and the IP is 10.10.167.159, and the port value, define the port value as well, and the port value is 5700. Now we define the port value as well, and the next thing is, now I need to mention the terminal details, executable details, and what is the architecture of the executable and what type of executable it is. So I need to mention those details here in this particular exploit code. Now let me mention that context. Context is the word, context function, and within that I'm mentioning the terminal details, and inside a square bracket I need to mention the type of terminal, comma, window detail, new window. And the next thing is I need to define the binary. Binary equal to context dot binary equal to, and the binary type is ELF, executable linkable format, and that's what I'm mentioning here. Inside the double quotation, I'm mentioning the name of the binary. So this is the next line. And again, I'm calling context. Now I need to mention the OS and architecture. And the OS is Linux, and architecture is AMD 64. It is 64-bit architecture, hence I'm mentioning this. Now I'm opening the remote connection to this specific host. And in order to do that, I need to use a function called remote. So let's do that. I'm first defining the variable called connect, and connect is equal to remote, and within the remote I'm defining both host and port details. So now I define the connect. Now in the next line I am bringing this connect variable, and I'm using a function called receive until, and within the function I'm defining the bytes, and within this I need to mention the specific string that is used to get the input from the user. So I need to use the exact string here, and I am just executing the executable once and try to copy this string. Now let me move to the same place. So this is the line. Now very important part, we need to define the payload here. So let's try to do that. Now the input is binary, hence I'm giving the small letter b, and within that I'm simply giving any random letters a, and I'm multiplying it with 40. And in addition to that, I need to give P64. I'm just mentioning the architecture here, and now I need to mention the address of the vuln function. And here I already copied the address of the vuln function, and I'm simply pasting it here with 0x. So this is the payload that we need to send through the connection. So here we successfully defined the payload. So what the payload exactly do? It will give the 40 A characters. After that, it will call the particular address. So once that particular executable receives the input from the user, it will parse all these detail, and it will try to move to this particular address. When it moves to this address, it will eventually be calling the vuln function. So that is how we are going to exploit this buffer overflow. Okay, now let's continue to create our exploit. And now we just already defined the connect variable by using the remote function, where it is giving the connection request to this IP and this particular port. Now all we need to do is simply calling this connect and sendLine function. Using the sendLine function, I'm going to send this payload by using the sendLine function. And similarly, I need to call once again that connection and making the shell interactive. So this is what our simple exploit. We successfully created this exploit. Now let's try to run this exploit and make sure it is calling the vuln function and giving us the shell. Now let's run that exploit and see what we are getting. So here is the exploit Python file. So I'm using Python 3 to run this. So after I executed, you can see I got this shell. If I give any input here, I'm simply not getting anything. It gives me nothing. So it is not still interactive shell. It is not giving me the desired outcome that I want, but somehow it gave the shell back to me. But we need to verify whether we got the perfect shell or not. So before that, let's see the red entries highlighted here. Here you can see a certain parameters. So PIE, NX, RWX, stack, RELRO, all these particular parameters are nothing but binary protection. For example, let's say PIE, it is one of the binary protection techniques. Currently, none of the techniques are enabled on this exploit, which made our exploitation process very much easier. Because if for example, if this PIE process, I mean, if this PIE protection mechanism is enabled, what will happen? Uh, Here in our exploit, we defined the address, the memory address of the val function, right? In case the PIE is enabled, this particular memory address will be changing dynamically whenever you load that executable. So you cannot exactly say what is the address of a function. So that makes the exploitation very much difficult. So that's what the role of this PIE. Like this, there are certain other protection techniques, but none of the techniques are enabled on this executable. As I said before, which is making our process very easy. That is how we got the reverse shell as well. So let's verify this shell. First of all, I'm using TCP dump to initiate the tunnel 0 interface. I'm just initiating ICMP listener. Let me give it once again. Now it is listening for ICMP packet. Now I am giving ping -c, and I'm trying to ping my local machine. Let's see what we are getting here. So this is my IP. Let me try this once again. Ping -c. I'm defining count 1, 10, 17, 10, 171. That is the local machine VPN, the tunnel 0 interface IP address. So I'm just giving one ping request. Here I can see the response. Uh, Actually, we successfully received the ping request from the machine, and which clearly indicates we got the reversal. I mean, we got the uh, exploit successful. So now what we have to do, we need to make sure it is giving the reversal back to our machine. Let me get the bash reversal syntax. Bash reversal pentest monkey. I'm just referring the cheat sheet of pentest monkey. So here is the line, one liner, and I'm simply gonna use this one line to define 10, 17, 10, 171. Let me initiate the netcat listener on some random port, LVNP 5050, maybe. Okay, now the listener is initiated. Let me modify the string to give the reversal. I mentioned 5050 port and 10.7.10.171. So I made sure my machine is leaning on port 5050. Now let me execute the same here. After execution, I got the reversal back. Now I am giving a command. I got the output here. So it is showing the list of files available in this directory, and also I can see the current working directory here, and I can see the document here, flag.txt. If I read this, I got the flag finally. Now let me put it here in this flag section. I did that, and the binary architecture, it is 64-bit architecture, and let me answer that as well. Yeah, I got it correct. And this is simply information. So finally, we did that. Reversing a binary and creating a small exploit to get the reversal. Actually, it was a totally new experience, totally new learning to me. Hope you also learned something new from this. If you really did, hit the like button, consider subscribing my channel, and if you have any opinion, put it in the comment section. You can also share this video among your friends. Next time, I'll catch you with another exciting video. Until then, I'm signing off. Love you guys.